Okay, everyone. So today we're going to be looking at monitoring changes in different populations. So essentially, what we're looking at is ways in which we can look to see how population changes over time, what happens when there is an impact on the population, and what the repercussions are. But really, just looking at how can we even monitor them to begin with is the main idea. Okay, so firstly, just to kind of redefine what populations are. So remember that populations are all the members of a particular species within the same ecosystem or habitat. So remember, an ecosystem or habitat that we can be discussing can be something small. So it can be all of the oak trees in a certain park. Or we can talk about it on a larger scale. So maybe all of the oak trees in Richmond Hill, or all the oak trees in Ontario or Canada or the world, right? So it can be a small ecosystem or it can be on the large scale. So in terms of global population, in terms of human population, there are lots of people that are born every day and that die every day, right? So it's a balance of growth and depletion of population. So actually this stat is a little bit old. We're actually approximately 8 billion people currently. So really what we're looking at are what are some of the things that can cause an impact to those changes. So over time, right, a population size can either add people to the population or remove people. So obviously I'm saying people, but really this could be, let's say rabbits or grass or lizards, right? It doesn't matter what the species is that we're looking at. There are factors that affect populations no matter what type of species there are. So there are four main factors that can affect a population size, and I've already mentioned a few of them. So number one is the birth rate or the natality rate. So essentially, how many offspring are born to a species that year. So let's say, for in the year 2020, how many rabbits are born on Earth, right? So we're talking about how many offspring are born in a particular year. Then, of course, unfortunately, the circle of life, we have birth and we have death. So mortality rate. So looking at the number of species, for individuals of that species, I should say, that die within 1 year. So if we're looking at how many rabbits are born in that year, maybe how many rabbits have also died in that year, right? So these two, there's not really anything that can avoid this, right? So every day, things are born and things pass away. It's a natural way of life. Now, the next two are more so when we're discussing a specific ecosystem. So we have immigration or we have emigration. So they sound kind of the same, but they mean different things. So immigration is where we're talking about how many individuals are moving into an area, right? So let's say I have a certain park and I'm looking at the number of let's use our oak tree example, okay? So oak trees is not something that can immigrate or immigrate. Oak trees cannot get up and move out of an area or move into an area. But let's say we were looking at the number of deer in that park. Okay, well, there might be another park way down over here that the deer are at. Why did I pick an animal that I know for sure I cannot draw? Okay, so we have a deer that's here. Let's say food is starting to run low. Well, that deer, or several of them, may move into a different park. So when you're looking at movement of living things, obviously, number one, it has to be something that can move. Okay, so for example, producers cannot exactly get up and walk away and go to another area. But if you're looking at something that has the ability to move, you can look at movement into an area or movement out of an area. So if we were looking at these two parks, the park here went down by a deer, so the population went down, but this park went up because the deer moved into that area. So population changes can be looked at. This is why it's important to look at different levels of ecosystems or sizes of ecosystems, because obviously if we were talking about, let's say this entire thing is Richmond Hill, the number of deer in Richmond Hill has not changed. But if we were looking at the number of deer in this park versus this park, let's say Park A versus Park B, the population is now different. This has one less, this has one more. But if we're looking at this entire area, the population is actually the same. They're just moving from one area to another. So it's important when you're looking at these factors to consider it, especially for number 3 and 4 here. You have to consider the size of the area and is it something that those individual organisms can actually move. Okay, so types of populations. So we have what's called an open population versus a closed population. Okay, so an open population is where you have all 4 of those factors we just discussed coming into play. So for example, Park A and Park B have all 4 population factors. So a deer can be born, a deer can die, a deer can move in, or a deer can move out, right? This can even apply to people living in Toronto, okay, or people living in Richmond Hill. So children are born, older people may die, people can move into Richmond Hill, or people can decide to move out of Richmond Hill. You know, maybe somebody moves from Toronto to Richmond Hill, and then maybe somebody moves from Richmond Hill and they move to Barrie or something, right? So all 4 of these factors are coming into play. So that means there is an open population. So you have movement that is available. A closed population is where you only have birth and death having an impact. So actually this here could be a good example for our oak trees, right? So if I'm looking at the number of oak trees in Park B, I'm not going to have any oak trees that are going to want to walk over into this park. And I'm not going to have an oak tree that's going to say, you know what, I'm going to leave this park and go to Park A. So like producers have a closed population, only birth and death, or I should say growth and death. Obviously plants are not really born the same way that how a mammal is born, right? But still, growth and death. Now, in terms of humans, okay, so the human population on Earth is considered to be a closed system. So people are born and die and they can move from maybe one country to another country. But it's not like we can say, okay, well, we're going to leave Earth and we're going to go on to Mars. We're kind of closed into the fact that we are stuck on our planet currently. That might change in the future, but currently we are a closed Earth population. Now, we're not closed here in Canada, which is great, but there actually are some countries in the world where they have closed populations for humans. So, for example, Cuba is one country where people are not allowed to come and go as they please. Same thing with North Korea. So that's obviously like a government stance that's been put in place. But in terms of human population, majority of the places on this planet, you have the freedom to move or sell your home or buy a home somewhere else and move around as you please. Okay, so now let's start talking about what are some of the things that can limit population? So we know that there's obviously a limit to kind of everything, right? So let's say, let's go back to my park analogy, okay? Okay, so in this park, we have, let's say over here, I have a little pond, right? There's some water. I have my deer, right? I have food for my deer, right? So let's say I have some trees or some shrubs, some things that they eat, right? And let's say this is like in the middle of a subdivision. So there's like a bunch of houses and there's roads. And maybe there's a road that's here. Okay, so this park has a certain limit on the amount of things that can live here, right? So there's only a certain amount of, let's say, space. So space might be a problem. There's only a certain number of trees that can fit there. Maybe for, let's say, the deer, maybe there's only a certain amount of food available or water available. there is a limit to how many things are able to live in a certain area. Okay, so these are called limits to the population, right? So it's not like, one day you're going to be walking by and there's going to be 1,000,000 deer living in this park. The number of deer is probably going to stay relatively the same because of limits that there are in the population. So same thing with, let's say, fish that are living inside that pond. Okay, there is a limit to how many fish can live within that pond. And for some of the same reasons here, there's only a certain number of space. Maybe there's only enough habitat for 50 fish. Maybe there's only enough food for 50 fish, right? So there is a limit to how many deer can live here, to how many plants can grow here, and to how many fish can live in this pond. So what we're going to be looking at here are what are some examples when we say limits on populations, what are some examples, and kind of what are the scenarios that they would apply in.